Okay, so in this video, we're going to continue to talk about logarithmic functions. And we're going to talk about how logarithmic functions have some certain interesting properties. So one property that we can talk about, this is called the product property of logarithms. And this says that the log base a of x times y is equal to the log base a of x plus the log base a of y. All right, and this is with a and b not equaling to 1. All right, and again, we have to make sure this only works when we're talking about values of the argument that are in the domain of the logarithm. But if these values are in the domain of the logarithm, then if we multiply them together, where their product is in the domain of the logarithm, and they're multiplied together, then the log base a of x times y is going to be the log base a of x plus the log base a of y. All right, so let's say that we look at an example. Let's say that we take the natural log of e times e. All right, well, one way we could think of the log of e times e is natural log of e times e is that's a natural log of e squared. Okay, and so this is asking what number must I raise e to in order to get e squared. Should be fairly straightforward that that's just equal to 2. All right, but if we use this property of logs, we can say that this is actually the natural log of e plus the natural log of e. All right, because that's a natural log of x plus a natural log of y. And the natural log of e is saying what number must I raise e to in order to get e, and that question mark here turns out to be 1. And over here, again, the natural log of e is 1. So 2 equals 1 plus 1, 2 equals 2, so that checks and you're happy. So essentially what we're saying is that the log, and in our case, we're going to mostly just worry about the natural log of two numbers multiplied by each other, where that product is still in the domain of the natural log, is equal to the natural log of one of the numbers plus the natural log of the other number. Okay, and that also matters whether or not each of those individual numbers are in the domain of the appropriate logarithm. So there's a few other properties that turn out to be useful. We can say the log base a of x divided by y. Okay, so we have the log base a of x over y, and this is going to turn out to be the log base a of x minus the log base a of y. All right, and again, in the cases that we're going to be looking at, it's going to be the natural log of x over y is equal to the natural log of x minus the natural log of y. And again, we want to make sure that x and y are both in the domain and that x over y is also in the domain. All right, and this property will help to take some derivatives of some more complicated functions. So there's a few other properties that are useful. Another one is what's called the power rule for logarithms. And if I write that in natural logs, that would be something like natural log of x to the y power. In this case, we can take the power and we can move it out in front, and that's y times the natural log of x. All right. Again, if we wanted to look at a certain example, let's say that we were taking the natural log of e squared. Well, we already saw on the other slide that the natural log of e squared is what must we raise e to in order to get e squared. And so it'd be e to the question mark equals e squared. And that question mark is equal to 2. All right, but based on this rule, this is also saying that this is 2, if I move the power out in front, times the natural log of e. All right, and the natural log of e, we also saw on the previous slide that this is just equal to 1, so this is 2 times 1. So this is 2 equals 2 times 1. So we should be happy that it works out. And that's also going to be a useful property to use for a bunch of different situations. So some other things that are useful to know is that the natural log of, or let's say the log base a of a is equal to 1. So that's basically saying that what power must we raise a to get a, and that would be a to the first power, so the log is equal to 1. And in the case of the natural log, that would also tell us that the natural log of e is equal to 1. All right, because e to the first power is equal to 1. We might also have something like this. We could say the natural log base a of 1 is equal to 0. And again, this is all considering the conditions that we've put on a. But this is saying that a to the 0 is equal to 1. And again, we can apply this in the case of the natural log, where we take the natural log of 1, and that's asking e raised to what power equals 1, and that's going to be 0. Okay, so these fundamental properties will be helpful when discussing how to take derivatives of functions that involve logarithms. Sometimes these properties will simplify the functions that we're looking at in a way that it makes it easier to take the derivatives.